Marina Bay Sands Integrated Resort in Singapore is the first integrated resort combined with the casino planned by the Singapore government. This fact is well illustrated in Moses Safadi's building design, which seems to have poker cards leaning against each other. The maximum slope of the Marina Bay Sands Hotel is 52 degrees, which is more than 10 times the slope of the Leaning Tower of Pisa. At the time of the design, all structural experts said it was impossible to realize the building. And even bigger problem is the hotel's roof. This boat-shaped superstructure is a huge and heavy structure that connects the three tilted buildings into one. The load of this huge roof was at risk of collapsing the inclined lower building over time. How the Marina Bay Sands mega project, called the miracle of the 21st century, was able to be completed safely. We have been studying in the following order for a semester: background and design issues, foundation, hotel towers, and Sands Sky Park. Today, let's learn about Marina Bay Sands Hotel from the beginning. Let's look at the foundation construction first. The Marina Bay Sands Hotel was built on reclaimed land, which caused many problems. The hotel is located above the CC line. The geological cross-section along the CC line is as follows. It's filled up to 20 to 30 meters underground by a marine clay called kalong. This is soft soils and too weak to support the building. This short clip shows the marine clay at the construction site of Marina Bay Sands. So, the engineers reinforced the land by using jet grouting method. It is a technique that pushes the soil away by strongly shooting water and air, and at the same time fills the empty space with cement paste. To overcome the weak soil problem, a lot of barrettes and board piles are inserted into the hard and stiff old alluvium layer, up to 30 to 40 meters. But there was one more problem. It was the high water pressure caused by the high sea level. To withstand high water pressure, a circular diaphragm wall was used instead of a conventional rectangular shaped wall. Let's look at a simple experiment. This experiment shows the circular cofferdam is stronger in pressure than the rectangular cofferdam because the force is evenly distributed on the wall. Therefore, the circular diaphragm wall, called D-wall, was a genius idea to drastically reduce the construction period because it does not require any internal supporting struts. This map shows the average excavation depth of Marina Bay Sands is 18 meters. The hotel's depth is 14 meters. In addition, the map showing temporary supports shows that they are not installed inside the circular diaphragm. So, we were able to solve the problem of weak soil and high water pressure and safely complete the foundation. Now, let's talk about the hotel towers. The biggest challenge with the hotel tower comes from the design. The sloping structure should stand on its own until it meets another vertical structure on the 23rd floor. However, according to simulations, the angle is so sharp that the east structure would collapse before even getting to the 8th floor. Then, how could the engineers solve the steep slope of the building's lower part? The most likely idea was to apply force in the opposite direction to prevent the building from falling over. But it was impossible in real life because the highway passed right next to the building. To solve this problem, the engineers moved the wire inside, not outside the building. It was a clever idea that applied post-tension method. Stretch and release the steel wires installed inside the concrete to apply force to the concrete and prevent the lower crack, which is mainly used for horizontal structures. In the case of Marina Bay Sands, strands were installed in a vertical direction inside the buildings. It was called a vertical post-tension method as the first technology to be tried. When the building went up, strands were installed together and were pulled hard. This prevented the building from collapsing and overcame the slope, as shown in the video. Along with this first tried technique, temporary bracing was used as the building rose to reduce the possibility of failure more surely. So the load of the sloping building was distributed to the vertical building through the temporary bracing. At this time, the load applied to the vertical building was also increased, so the strands were also installed inside the wall of vertical structures. And transfer trusses were installed on the 23rd floor. It transfers the load of superstructure from tilted structure to vertical structure, reducing the load transferred to the tilted structure permanently. This transfer truss is designed to allow the vertical structure to bear more load to enhance the safety of buildings. As a result of simulating the load distribution of transfer truss by the truss analysis software, it was found that the inclined structure bears about 40% of the total load. After the transfer trusses were installed, the building could go up safely. Finally, the building overcame a lot of challenges and was safely built up to the 55th floor. And now, it's time to move on to the next phase, the Sands Sky Park. When the load is applied from above, the inclined structure is easily destroyed. Sky Park is a very large and heavy structure that exceeds 60,000 tons. The Sky Park is longer than the Eiffel Tower and even is located above the ground 200 meters. Let's look at how this ridiculous structure is maintained without collapsing on top of 3 different buildings. Sands Sky Park is divided into 5 distinct sections by 4 movement joints. More specifically, Tower 3 section had cantilever section. 3 of them, Tower 1, Tower 2, and Tower 3 sections, were directly connected to the hotel building. W-shaped columns and central lift cores were connected to the hotel buildings to support each zone. Thus, the load of the tower section was delivered to the hotel building and safely to the foundation, along with the hotel tower. Next, the bridge section's load distribution. They connected between buildings and looked as if they were floating in the air. How is this possible? These bridge sections consist of 3 giant steel trusses, which were over 350 tons and over 50 meters span. On the trusses, cross-girder beams were placed at intervals of 4 meters. The load is safely passed along them to the shear wall of the building. So, the load on the bridge sections was transmitted to both ends through cross-girder beams and trusses, and the transmitted load could be safely transferred along the shear walls to the foundation. So, how does the cantilever part not collapse? The reason why the longest cantilever deck in the world could be safely sustained without collapsing was the steel box girders. These heavy steel box girders were located on Tower 3, supporting the cantilever part. After two main steel box girders were placed on Tower 3, 6 steel box girders were connected in order, which formed cantilever section. Also, columns were embedded in the main box girder and connected to the hotel tower. The box girders with this variable depth was connected to the hotel and carried the cantilever's load to the building to support the cantilever. As such, the main frame of the Sky Park is divided into 14 segments because it was the most practical method for building Sky Park. However, they are hundreds of tons, and cranes used in general construction sites can lift up to 20 tons. How could these steel frames, assembled at the ground, form the Sky Park? Strand jacking system is the key to lifting hundreds of tons of steel structures, a heavy lifting method. Strand jack is a hollow hydraulic cylinder with a set of steel cables called strands passing through the open century, and the bundle of strands pass through two clamps, top and bottom. Two clamps, top and bottom, are the principle of heavy lifting. First, the top clamp grips the strands, while the bottom clamp does not, and the strands move up almost 55 cm at one time. And the bottom clamp is tightened and locks the cables in place. At the same time, the top clamp releases the cables, and not the strand, the cylinder moves back down for the next pull-up. Top tightened, bottom released, and cylinder moves up again. By repeating this process, this lift unit can lift heavy structure at almost 20 meters per hour. So, finally, we completed the Sands Sky Park. Marina Bay Sands has become the most iconic architecture in Singapore, providing people with a lot of amenities and amazing experience. During this semester, we have studied from the design to completion of Marina Bay Sands Hotel. After facing and overcoming many challenges, people are challenging and overcoming them again and again. Thank you for listening for this semester. Thank you.